Hey, how you doing? This is Aaron here. I've had a good few people asking me how I obtained the James Webb raw data and what's involved in processing it. So I'll do a very quick video on just how to obtain the raw data and roughly how to process it between PixInsight and Photoshop. So I'll just dive in because there's a fair bit in putting this together. So if you just go to the link that I've just highlighted at the top of the screen here, I'll put a link to it in the description of the video so you can easily get to it. But this brings you to where they publish all of the images that you can download. The next thing that you should do is go to the advanced search, so click there. And then in here you can filter for all the different telescopes and images and all the different types of instruments, equipment, whatever, for the various different things. So like you can get it for Hubble, you can get it for James Webb. But what I'm going to do is I'm interested in the mission here, so click in the mission. It's going to be James Webb Space Telescope, and then the instrument, I'm going to click on show 214 more and then scroll down. I'm interested in the near infrared camera, so you can see it here, NIR cam. Just tick that, and then you can see even just here there's nearly 90,000 results just left to filter from the near infrared cam. You need to get it down to very few, otherwise this will just sit searching for ages. So in the target name here, I know that the Pillars of Creation is one of the targets that I was working on, which is M16. So I'm just going to put in M space 16, and then that should return a few records. So you can see here it's already found it, so it found 6 records. So if I click search then on the top left, and then that's returned each of the wavelengths. So you can see here you have the results for the James Webb Space Telescope, and you can see the filters here of 187N, 444W, 200W. And you might ask what these are. So these are basically different filters that are used with the infrared camera on the James Webb Space Telescope that collect different wavelengths of light. So at the lower number here, say the 91, these will be your cooler colors like blue, etc. And then up at the higher range, say 444, that would be your reds. So it kind of moves from the cold colors into the warmer colors. There is a palette for this, and if I just go to here, and if you put in James Webb color palette, so if you do a search for, and I'm not a robot, okay, pick all the stairs. And then if you go to images, then so you can see here these are the color palettes. Now there is another one that I normally use. Let me just see, find it here. Yeah, this one. So this is the NIR cam filters, and you can see that the blues are in the wavelength of F150W2, and then you can see, so if you have any particular filter, which I'll just flick back here, so you can see we have a filter here of F200W. So if we go back to here, you can see there's F200W. It's kind of a turquoisey color. So when it does actually come to processing the image and you're trying to assign colors, this gives you kind of a guideline of what you can set the colors to. But it's kind of up to yourself what you want to set them to get the image that you're looking for. Anyhow, so we'll go back to here, but you're only really looking for a small file within these. So I'm not going to select them all. What you can do is select them all and then click add to basket here and then select the images, but just for demonstration purposes, just for speed, I'm just going to select one of them, and then I'm going to click on the add to basket. hopefully this comes through quickly. So you actually find that a lot of these files that are uploaded here there's a ton of information in them of stuff that you don't need. A lot of calibration data, a lot of maps, etc., that are used for building out some of the data on the system. So I'm just expanding it out here, and you can see if I just expand this. So this is the data that's within that file. So if I had clicked on the original file and just clicked download, it would download all of this information. So you can see there's a segment file, a JSON file, whatever a pool file is, association pool, catalog file, and then you have this file here, which is the one that you're interested in. So it's still quite a large file. It's 3 gig in size, but you're not downloading all of the other nonsense that comes with the download. So you just select that i2d fits file, and then you can click download then. So if you had done what I was saying before I went into this directory, where you select all of the files that are there of the different wavelengths, and then you just give it time and it loads all the files in here, you just expand all of the folders and only select the very last one in each one of them, so the i2d.fits file. And then once you click download, then it'll put them into a zip file and store them in your downloads directory, wherever you've set in your browser. And then from there, then you can unzip the files. So that's how to obtain the files or the data. Let me just see if I have it here. So I'm just gonna, this is one of them that I pulled down and I've unzipped. So it'll come in this zip format here. Sorry, let me just go back. So this is the 723. It'll come in this format here, and then if you go into the file, you can see you have each one of your wavelengths, and then when you go into it, then you have this fits file. So let me just go back to the directory. I'm interested in this folder here, and I wonder actually, yeah, we'll use this one as an example. I think this one is the Ring Nebula. So I'm just going to go back into PixInsight. Actually, I still have this one open. 2733 was the Ring Nebula. So just in PixInsight here, I'm going to browse to some of the files that I've downloaded. So I've got the file open. Back to James Webb. So this is the Ring Nebula. So I haven't processed this yet, so I'm just going to step through what I normally do for each one of these, and it'll give you an idea. So the first thing that I do is open each one of these. So I'm going to go to the 90 wavelength first, go to open, and you'll see actually with these fits files it loads 8 different frames. It loads, or seems to load, the calibration frame along with the actual image that you're looking for. So you can see all of these opened here. If we stretch the first one, just click on that, click stretch, so there's nothing in that one. Stretch this one, so you can see these are all different calibrations that it was doing. Stretch this one. So the main thing that you need to know is that you close all of these, and the very last one that you have here is the actual data. So if I stretch that, this is the wavelength, the 90 wavelength image. So I'm going to rename it just to make it easier for myself. I'm going to get rid of all of this and get rid of that, call it F90W, and minimize it. So I'm just going to put it up here for now, and then I'm going to just continue on doing the same. So I might speed up the video for this one, just so that you're not sitting watching me going through all this. we have our different images that we're going to process, and I'm going to start with one of the higher wavelengths because it seems to be, a lot of the time the data seems to be clearer at the higher wavelength. So we'll start with this one. The first thing I'm going to do is I like to do a dynamic crop just to try and tidy it up a little bit, and then we'll apply that then to all of the other images. So this is going to be very rough just to give you an idea of how it works, and then I usually keep that open and then go through each one of these. So you just take that, drag it onto this. Okay, nice. This. You can see there's probably going to be a lot of kind of artifacts after stacking these, because this data doesn't seem to be as clear now as the pillars of creation. I'm sure we'll try it and see what it's like. It'll give you an idea anyway of the steps that I took for the pillars of creation, so that even if this isn't clean at the end, at least you'll know what you need to do with the clean data. Just click on my original image then. Okay. And then the next thing that we want to do is just to we'll do a star alignment on them, or maybe we'll do the stretch first. We'll do a star alignment. So if I go to process, and then I think it's under image registration, star alignment, and then we set our referenced image as being this one here. So this is the 444 470. So I'm going to click on select image 444 470, click OK. Now some people recommend when it comes to star matching here, sorry, let me just start detection. Star matching. Sorry, yeah. Some people mention when you come to star matching that you should set a preview on all of these and then restrict it to the previews because it's quicker. But I actually found that when you do it with a preview, it aligns the preview area, but if there's any of the stars on the outside here that aren't aligned, that in your final result it's way off. So I just leave it with this unticked, and then I align all the other images. So let's go into this one, and then you just drag this onto that, and it'll generate a whole new image, and you just basically rename it to specifically what it's going to be. So you can see this is the registered one, F90 registered, right? So I'm going to shrink that down, drop it down here. These are going to be the ones that we're going to work with. So put that back. I'm going to go with 187 next. So we're just going to minimize this, drop it down. Next one. Now, there's nothing to stop you either if you're familiar with narrowband imaging and you don't want to do the full color profile and save all of these. You could select what will be the best data out of the list here and do maybe a HOO or some sort of a blend of the data to just get a final result. So I haven't even got to that level of playing with it myself. I only really process the Tarantula Nebula and the Pillars of Creation, and the data was amazing to work with. The Pillars of Creation data was incredible. I actually went looking for it to process for this, and it seems to have gone missing, so I don't know whether I accidentally deleted it. I hope not. But I have I might have just been very efficient. I have the output images which are already calibrated and ready to stack, and maybe I thought sure I won't use them again and remove the originals, because as you've seen they're quite large. So this one. I think that's it. So this is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and then you have the original one, and everything is referenced off this anyway. So what we're going to do is just to keep it clean, I'm going to create a clone of that, and I'm going to rename it to registered, which it isn't really registered, but just for tracking purposes. So all of these are now, or should be, the same when you overlay them. So the next thing we have to do is stretch them. Now you can go with an STF stretch and then histogram transformation to do a quick process on them, but I actually found that it kind of messes up the color profiles. It doesn't really do it nicely, so I'm going to do each one individually. So we're looking for the 90 registered, and we're going to say show, and then we'll just do a quick stretch on these. Just take me a few minutes here. So you're just looking to do kind of a soft stretch on them. You don't want to drag it out that you're blowing out everything in the image. You just want it to show up some details. Actually, look at the galaxies even that's in here. This is amazing. So you don't notice it until you start processing these, because the standard stretch that's in here overstretches everything. But look, you can see galaxies everywhere. It's incredible. Okay, so on to the next one. Get distracted. So 187, and we're going to say preview. That's not the 187 preview. Let's go on. Okay, so we have all of our images now that we're gonna use for processing. So the next step is to export all of these then as TIFF files. So go into this one, file, save as, and then James Webb, go to the Ring Nebula, we'll say processed, and this is the F90. Save, and it has to be 16-bit so that you can pull it into Photoshop. Now there is a lot more that you could potentially do in here. You can do noise reductions, you could do stretching, you could do different transformations on them to try and reduce some of this, the artifacts and stuff down. But just in the interest of time and just to see what we'll get out of it, we'll just bring them out as is. So 187, save that, 16-bit integer, that's fine. Collapse this one down, 212, file, save as, what did I do there? File, save as, no way it gave me that option. What is the difference? Okay, we're just gonna try it for now. I can change it to 16-bit. Oh yeah, being stupid. It's been a long day. Okay, file, save as, save 16-bit integer. Collapse that down. File, save as 16-bit integer. Okay, collapse that down, and then this one. File, save as, save 16-bit integer. Okay, so very quickly, the next step is to bring them into Photoshop, and we'll try and add some color and just see what it looks like. So I'm looking for the Ring Nebula data processed, and that's all it is. So I'm just going to bring in the F91 first, and just make sure it opens properly. And then we'll rearrange them then based on. So this is the bit we need to be careful of now. So just move this. So you need to name them as they're coming in, otherwise you get confused with which one is which. So I have F90, and then I'm going to go back to here. We're interested in 187 next. Open in Photoshop. Actually, you know what I can do? I can open each one of these and then copy paste them in. It'll be the easiest way. So we go to 187, Control A, Control C, go back to here, Control V, rename that, to 187. I'm just going to call it 187. I don't know what they are. So then we have 212, Control A, Control C, back to here, Control V, and then we have 212, and then the next one we have is 365, Control A, Control C, Control V, this will be 365. Oops. And then we have 405, Control A, Control C, Control V. We'll just call it 405 by itself. And then the next one is 444, which is this one. Control A, Control C, go back to the main one, Control V. Say 444. Okay, so I'm gonna stick the cooler colors up the top, so we'll just organize them now by their numbers. So 90, 212, sorry, 187, 212, 365, 405, and 444, right? And then if you want to look at the data that you have, you can just deselect them as you go, and you can see there's a very significant change in the data as you're going. So usually what I do as well is I'll start at this layer, and then I'll just select them one by one and just make sure that everything's aligning as you'd expect, which it is if you look at where your stars are as you're doing it. So I'm going to go to the next one now, do the same thing. Yeah, stars are aligning perfectly. Next one, again, stars are aligning perfectly. Next one, same again. And the next one, same again. So what we're going to do now is we're going to start blending the data. So we know that 444 is going to be a red color. So the first thing that we're going to do is we're going to go to an adjustment layer. Actually, sorry, the first thing that we have to do, because this is a grayscale image when you first import it, it defaults the image canvas to grayscale. So you actually need to go to image, mode, change it from grayscale to RGB color, and then choose don't merge. And then first thing we're going to do is right click, sorry, not right click, you're going to go to apply hue saturation. We're going to colorize it, and we're going to leave it as the red color. And then we won't play around with any of these just yet. I'm going to leave saturation as it is, the lightness as it is, and that's that one done. Then we're going to go to the next layer. We're going to do the same thing again. We're going to go to adjustments, hue and saturation. We're going to colorize it, and then I'm going to hold down shift on my keyboard and just hover over this, or sorry, alt, it's not shift, alt, and then see when you get this little arrow here, it allows you to clip it to the layer. Means then that you've pinned it down. And then what you need to do actually is, because this layer here is sitting on top of this layer, if you leave it as is, it will block everything. So what you need to do for each of these following layers, you don't do it for the bottom one because the bottom one is the base layer, but for any following ones you need to change it to screen, and then you also need to change the opacity to 50%. And then we're just going to go back into hue and saturation. The color here should be a slightly different color, right? So leave it at that. And then we're going to continue on. So we're going to go to this layer. And I'm going to say, first thing I'm going to do is set it to screen. And I'm going to set it to 50%, thereabouts. And then click on the layer, click on adjustments, hue and saturation, set it to colorize. And then we are going to set the color of this one based on the palette. So we need to go back to, I think I might actually have a copy of that in my James Webb folder that I kept. Colors, and here we are here. Okay, so my color palette is saying that for the layer 365, if I go to 360 is kind of yellow. Can I see 365 here anywhere? So we're going to assume it's in that range, right? So I'll just, maybe it was 356 and not 365. So I'm going to change it to being a kind of a yellowy color. It's okay. And then we'll just leave the lightness and saturation, everything as it is. And then hold down the Alt key on your keyboard, and then clip it to the layer. So you can play around with all the different settings that you have here. So you're going to have your base layer, your hue and saturation, and this level. I just wonder actually, you shouldn't need to clip it, right? But I'll see if I clip it, what difference. There's no difference really yet. So what I would do then is just to see processing wise where we are. I would add another adjustments layer, maybe do a level adjustment, and just see, and you can see here we're way off with the level. So just to give us an idea, so you can see all the colors coming into this already. And maybe if we just brought that down a little bit here, and then brought this one up a little bit now, maybe down. Wow, look at the details in this thing. Now it's unfortunate because see some of these layers here that you have these artifacts, and you could probably try and get rid of some of those layers just to see which one is causing a lot of that stuff. Like that one there, that layer is horrible. Now you could probably replace that 187 layer, or you could blend it. You could select the layer and try and reduce some of that stuff out. So you could go in with the eraser and drop the hardness down, and maybe blend some of this out. You can see here, and then you can keep like the nebula with all of the detail in it then, because at least then you're not losing that color, but you're not affecting the galaxies that's in the background. So anyhow, so I'm just going to do Control Z there. I'll just go back to before I done that, because Gives you an idea then of what you're starting with and what the colors are going to look like. What you can do then is you can go to each one of the layers separately and say, well, I'm gonna have a look and play around with what the lightness would look like, so you can see here how that affects it. I think that makes a massive difference. So you can drop the lightness down, increase the color, so maybe just down a little bit, and all of a sudden then this is starting to pop a lot more. So drop this one down a little bit. You can see a lot more of the detail. Now when doing that, you're kind of losing some of the detail in the background, so you might want to do different layers and adjust them so that you get a different effect. So you can see here, if I bring that up, it's going very red. If I drop it down, you get a kind of a more natural color. Look at the details in the nebula though. Incredible. And then you can also then play with your hues and saturations then to give you different variants then in your colors. So I actually kind of like this effect over here. So you're getting that kind of purpley tinge in it. Let's see what we get here if I drop this one down. Yeah, so the colors that they give you are a guideline. You can play around with them and see what you think. Now for me personally, I like to have a look and see what we can apply to bring out the most detail and what gives you kind of a different look at different parts of the nebula itself. So kind of like pull that down a bit, because that was, you can see the difference in when you have that bright, the artifacts it was bringing. If you drop it down, you still keep the detail in the nebula, but then it gets rid of a lot of those artifacts. And then let's have a look at the color schemes here. I think I like it when it's up to about here. And let's play with the colors. Now some people would shoot me for this because they think it has to be a specific color and look a specific way, but to be honest with you, I think as long as it's bringing out all the details and it looks incredible, then I'm happy enough with it then. Anyhow, could be sitting here playing with it all day. This just gives you an idea of what it can do and how it works, etc. You can follow the color palettes that they give you from the James Webb Space Telescope, these color palettes here, and then you can do color calibrations and adjust all your levels, etc., and try and get out the same kind of end result that they ended up with. Or you can do what I like to do, is just go with your own kind of processing technique and try and bring out details that they didn't, or that you have a different eye for it, of what way you think it would look nice. Obviously these wavelengths of light are specific to the color spectrum, so you are kind of deviating from what it should look like, but these things you can't see them really anyway, they're gas clouds, so I think it's fair to apply whatever color you want. Anyhow, I hope this tutorial was of benefit, and I hope it helps you with the processing of the James Webb data. All the best and clear skies.